Good day, students. Welcome to mathcodeserve.com. In this clip, we're going to be going over problems 6 to 10 of the June 2015 Algebra 1 Common Core New York Regents exam. All right, let's take a look at problem 6. It reads, Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? All right, so one thing to note when you're solving a system of equations is that if you want to eliminate a variable from a system of equations, you just simply have to make the coefficients from the two equations opposites of one another. All right? So these are the steps we're going to use to solve the problem. We're going to declare our variables first, and then we'll set up our equation, and then eliminate the variable that we do not want to find the variable that we desire. Okay, so let's go ahead and carry out step number 1. We're going to declare our variables. So this is our declaration. Let A be number of pounds of apples, and then let P be what? The number of pounds of peaches, okay? Alright, now that we have our variables declared, we can start to set up a system of equations using these variables, okay? Let's start with our pounds equation. Pounds equation. So what do we know about the pounds? Well, we know that if we add the total number of pounds of apples, A, plus the total number of pounds of peaches, P, we get the total pounds that she sold. So how many pounds did she sell in total? She sold a total of 165 pounds. Okay? Next, let's set up our cost equation. All right? Or earnings equation, you can call it. Yeah. Earnings equation. How much did she earn? Earnings equation. So if each apple sells for $1.75 and she sold 8 apples, then she earned a total of $1.75 times A. Okay, for apples. And then for peaches, do you see the term for the total number of dollars she made from selling peaches? If she sold P peaches and each of them cost $2.50, she earned a total of 2.5 because of each peach times the number of peaches she sold, which is P. So 2.5 P. Okay? So the earnings from apples plus the earnings from peaches should give us the total earnings. What was most total earnings? 337.5. So 337.5. So here goes your system of equations. Now we're asked to find the number of pounds, so we want to find P. Okay? So if we want to find P, what are we going to eliminate? To find P, we have to eliminate A. Alright? Now how do we eliminate A? Remember we talked about it earlier that if you want to eliminate a variable from a system, you want to create opposites. So what is opposites with the coefficients, okay? So what is the opposite of 1.75? The opposite of 1.75 is negative 1.75, okay? So we simply multiply the first equation by the term or the number that yields an opposite of the coefficient of the A in the second equation. So that is negative 1.75. Now don't forget to distribute. We're going to distribute this negative 1.75 to every single term. If we do that, that yields negative 1.75a minus 1.75p is equal to negative 288 0.75. You can do this with your calculator, okay? And 1.75a plus 2.5p is equal to 337.5. Now, why did we do what we did? We want opposites coefficients for the a so we can eliminate a and get p, all right? So we have that here as perfect, so we just simply combine the two equations. Upon combination, you get 0.75p equals 48.75. All right. Now, last step is to isolate p, the number of pounds that she sold. So to get p isolated, simply divide by the coefficient of p, both sides. Coefficient of p is 0.75. If you divide this out in your calculator, you will get p equals 65. So our answer is option number 3. All right, let's take a look at problem 7. It reads, Morgan can start wrestling at age 5 in Division 1. Okay, he remains in that division until his next odd birthday, when he's required to move up to the next division level. Which graph correctly represents this information? Now, in order for an input to have a defined output, something to note, you must have a closed point at the vertical trace of the inputs to the graph. Okay, so when you're tracing an input to a graph, if you have an open circle like in option 4 here, then that's it's not defined for H7. Okay, you must have a closed point in order for the output to be defined. So for 7, here you have a closed point, so the output is 1. All right, so just keep that in mind. Steps we're going to use, we're going to examine each function, the step of each function, and then whichever one matches the description here, that will be our correct answer. Okay, so let's go ahead and just write down some points. At age 5, Morgan is in Division 1, so the correct graph has to have 5, 1. The next odd birthday is 7, age 7. What does Morgan do at age 7? He moves up to the next division. After 1 is 2, so at age 7 is at Division 2. At age 8, oh snap, sorry, we're going by odds. So at age 9, he's going to advance to Division 3. So what you're going to do is examine the steps of each function and see which is consistent with this pattern. When I say step, I'm looking at here, right here, see there? Look at that for each function and see which one is consistent with this description provided right here. Okay? All right, I'm going to skip 1 and start with 2. I'll tell you why later. So if you take a look at 2, if the input is 5, what's the output? If the input is 5, the output is undefined. This is basically saying at age 5, he has no division. Is that what the problem says? No, the problem says at age 5, he should be in Division 1. So this option is wrong because this point right here, 5, 1, is not present here. Okay? Now let's look at option 3. At age 5, the output is Division 1. Excellent. So this works. Now, let's move on to age 7. What's happening at age 7? At age 7, you have 2 points. At age 7, he's in Division 1 and he is in Division 2. Now, does that make sense? Can one person be in 2 divisions at the same time? The answer is no, because based on our points here, when he is 7 years old, he must be in Division 2 and Division 2 only. He cannot be in 2 divisions at the same time. So because of the conflict here, 2 outputs for 1 input, this is not a function. This does not work. Option 3 is not the answer. Okay, now let's look at option 4. It's kind of interesting. Same situation here. At age 5, he's in no division. At age 7, he's in no division because you have 2 open circles. At age 9, he's in no division. So none of these points here even fit here. You don't have 5, 1 included here. You do not have 7, 2, 9, 3, none of them. So this is absolutely wrong. Okay? All right, now let's look at option 1. At age 5, he's in division 1. That coordinate is 5, 1. That's excellent. At age 7, you see what happens here? It's this open circle. He is in division 2. So this point is 7, 2. That works. At age 9, he jumps to a division 3. This point right here, the coordinates is 9, 3. And the pattern continues on and on and on. Okay, so this is the correct answer. All right, let's take a look at problem number 8. Problem 8 reads, which statement is not always true? Okay, so before we take a look at these options, just a real quick reminder. All right, just a real quick reminder. If you multiply two rational numbers, you get a rational number. For example, if you have 1/2 times 1/2, you get a rational number, which is 1/4. Okay? Number 2, if you add two rational numbers, let's say 1/2 plus 1, you get a rational number. All right? Number 3, if you multiply if you multiply a rational, let's say 2, and an irrational, root 3, you get 2 root 3. Irrational. Remember, rational numbers can be expressed as a ratio of two integers, positive or negative. Irrational numbers cannot. They are non-repeating, non-terminating decimals, or radicals that cannot be simplified into integers. All right? So there you go, you have rational and an irrational becoming an irrational. Number 4, if you add a rational, let's say negative 1/2, and an irrational, root 1/2. Oh, that's rational right there. Let's pick another example. Root 3/2. If you add a rational and an irrational, you get this number right here. Since this number has a rad 3, it's irrational. So rational plus irrational is irrational. Okay? All right, let's take a look at reminder number 5. If you multiply an irrational and an irrational, you have an interesting situation. You either get a rational or irrational. Okay, let me give you an example of both cases. Root 3 times root 2. The product of these two is root 6. This is irrational. All right. Now, what if I multiply negative root 2 times root 2? These are two irrationals, but when I multiply them together, I get negative root 4, which is equal to 2. I'm sorry, negative 2. Okay? What is this? Rational. So whenever you multiply two irrationals, you get irrational or rational. Now, when you add two irrationals, you either get 0, which happens to be irrational, a rational number, or an irrational number. Okay, let me show you examples for both. So if you do root 3 minus root 3, or negative root 3 plus root 3. Okay, so you add in a positive and a negative irrational that are identical. So what do you get here? You get 0, which is rational. Now, what if you do root 3 plus root 3? You get 2 root 3, which is irrational. Okay, so in these two cases, you kind of have interesting outputs. You don't have exactly what you started with. Unlike rationals, when you multiply two rationals or add two rationals, you end up with rationals. But in the case of irrationals, the output is a little bit more complicated. All right, so with this reminder here, let's see if we can determine the nature of the results from these operations here. Now, when you add two rationals, you get a rational. That is always true, always. The product of two irrational numbers is rational. Now, is that always the case? Let's take a look at reminder number, which one are we looking at? It's 5. Notice we talked about it earlier. We said if you multiply two irrationals, you can get rational if the radicands are identical, or you could get irrationals when the radicands are different. So statement 2 is not always true. Not always true. Okay? Only when the radicands are identical. So this is the answer right here. All right. Number three, sum of rational number and an irrational number are rational. Rational, irrational, always rational. That's always true. So that's good. And then last one, rational, the product of a rational and an irrational number is irrational. Let's see, rational times irrational is irrational. This is always true too. Okay, so the answer is option number 2. All right, let's take a look at problem 9. It says the graph of the function f of x equals the square root of x plus 4 is shown below. So you have the graph of a radical function that has been shifted 4 units to the left. The domain of the function is, now one quick reminder is that the domain of a function is the width or horizontal span of the graph when the entire graph is projected on the x-axis. Okay, so for domain, you're looking at the x direction. How about the y direction? What is that called? That is called the range. The vertical span of the graph is the range. Horizontal span is the domain. Okay? So these are the steps we're going to follow. We're going to project the graph on the x-axis. And then we'll sketch the projection like a number line. And then we're going to write what the equation of the number line is. That will be the domain. Okay? All right, so let's project this graph on the x-axis. What on earth does that mean? Think about this being a line and you have a flashlight. If you shine a flashlight on this graph from the top, okay, what kind of shadow will be formed on the x-axis? So there goes your flashlight right there, flashing the light from the top on this entire graph from -4 all the way to infinity. We have this infinitely wide flashlight. What will the shadow look like? The shadow, when it's projected on the x-axis, will look something like this. Bam. All right, let me change the color. Let's make it blue. Okay, so that's exactly what you get, the projection of the graph on the x-axis. Now, how wide is this line? Where does it start from? How far to the left does it go? How far to the right does it go? This is a linear, this is a graph of a number line, okay? So what's the equation of this number line right here? The equation is you're going from -4 all the way to infinity, so x is greater than or equal to, since we have closed circle, -4. That's your domain, okay? So domain is the set of x's such that x is greater than or equal to -4. Answer is option number 4. Now, what if the problem doesn't ask for it? What if the question asks for your range? For your range, what you do is you take your flashlight, you put it on the side, and then you project your graph on the y-axis. The vertical span of your graph is your range. Okay, so it's going to look something like this. It goes up forever. Okay, so that's what the projection is. From the, you're going to flash it from the left and the right. This projection goes here, this projection goes here, that projection goes there. Okay, so you're projecting the graph on the y-axis. Now, if you take a look at that number line we just drew, let me make it green. What is the equation of that number line? That is your range. In this problem, the range is y, because we're going in the y direction, such that y is greater than or equal to 0. Okay, the problem didn't ask for this. I'm just going over it because it might be the question you see on the next test, so keep that in mind. Range goes in the y direction, up and down. Domain goes in the x direction, left and right. Okay, all right, let's take a look at problem 10. Problem 10 reads, what are the zeros of the function f of x equals x squared minus 13x minus 30? Now, a quick reminder is that the zeros of a quadratic function are the solutions to the related quadratic equation in standard form. Okay, so this is a quadratic function right here. The related quadratic will be this expression set equal to 0. That will be the related quadratic equation. So the solution of that, or the roots of that, is the zeros of this function. Okay, Now steps, we're going to set the function equal to 0 because we're looking for the what? For the zeros, right? We're going to factor by grouping, and then we'll use the zero product property to determine the x values that cause this function to attain values of 0. Okay? All right, so let's go ahead and find the related quadratic equation, which is x squared minus 13x minus 30 equals 0. Now let's go ahead and play our x game. Now this is a very tricky problem because you'll see in a second, we have negative 30 and negative 13. Now for the x game, you want to find two numbers that multiply to give you negative 30 and add to give you negative 13, okay? So let's put 30 there. So the tricky thing about this problem is that you have two sets of numbers that actually yield 30, but only one set can satisfy this sign requirement, okay? So we have 1 times 30. It doesn't work because this gives you 29 or 31. 2 times 15. Oh, this gives you 13. Okay, so this is a potential candidate, but also 3 times 10 gives you 13. So this is a very tricky problem because you have two pairs that work. So if you do not pay close attention to the signs, you can easily pick the wrong pair. Okay, so I'm going to go ahead and pick the wrong pair first, just to illustrate. So let's pick 10 and 3. Now, can the signs work? Here's a question. Since the sum is negative, these two, well, the sum is negative and is bigger than both of them, so they both have to be negative in order for you to get negative 13. All right? So 10 times negative 13 is negative 10 times negative 3. Is it positive negative 30? Is it? The answer is no. Even though it works for the bottom, it doesn't work for the top. Whatever numbers you have here must work for the top and bottom. So if I say, okay, let me change the sign of the 3 to negative, it works for the top, right? Negative 10 times 3 is negative 30. Perfect. But does it work for the bottom? No. Negative 10 times 3 is negative 7, so that doesn't work. If you switch the sign of 10, you still run into the same problem at the bottom. So the correct option is 2 and 15, okay? Even though this is the correct option, you still have to be careful with the sign. Now, the sum is negative, so the bigger has to be negative. So 2 times negative 15 is negative 30. 2 minus 15 is negative 13. Excellent. That's what we want. Okay? So since a is equal to 1, we don't have to factor by grouping. We can skip directly to the factored state, which is x minus, take this 2 right here, times the quantity x. Okay, this is positive, right? So this is x plus 2 times x minus 15. You have to be really careful with the signs here so you don't get it wrong. Okay, so there goes the factored state equals 0. Now we factored by grouping. Now we're going to go to step 3. We're going to use a zero product property, okay? So the product of these two equals 0. Either x plus 2 is equal to 0 or x minus 15 is equal to 0. Solving algebraically, the left one you subtract 2 from both sides, and then that yields x equals negative 2, and on the right side you add 15 to both sides, and then that yields x equals 15. Alright, so our answer for number 10 is option number 4. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial helpful in your preparation for the Regents exam, please give us a thumbs up. We'll appreciate your positive feedback. If you have any questions, feel free to ask the question in the comment section below, and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to the remainder of this review series. And don't forget our interactive practice tests to sharpen your skills in preparation for the upcoming exam. More clips can be found on mathgoodserve.com. Thanks again for watching and have a wonderful day.